Alright, last time we already know something about files, okay? I already tell you how to change the timestamp. Change name, you already know it. It is a move command. Where's my remote? Hey, why is move? Hey, move. Okay. So, changing ownership, changing permission, you already know about change mode. Usually you put something on the web, you need to do change mode. Actually, there is a change mode system call. So I already written here. This is a system call for change mode. It's as simple as calling the command. Okay? But wow, what is change own? Last time we were talking about ownership. So ownership of file. Let's say you have a root file. You want to give this file ownership to your maybe account called TY Wong. Okay? So you can do the change ownership. Why does so soft sound? Okay, better. Right? And last time we know that we can use the touch command to change timestamp to whenever time you want. Okay? Now, we are going to look into some even more exciting aspect. Okay, so what is exciting aspect? I will disclose to you why we have to shut down the computer but not just pull the power plug. We will explain why you need to push eject button when you want to remove the USB. Now, when you open a file, okay, this opening flow comes again up. So you will call open and go to the hard disk. Now you understand that hey, there's a bunch of data inside a hard disk. There contains some information about the file. So the information will be this bunch of things: the name, the size, the permission, ownership, when it should be updated, about the access time, modification time, so on and so forth. Now, this kind of data, we usually call it metadata or attributes. This will be looked up from the hard disk. Let's say you want to open a file called abc.txt. At least you have to take a look at the file. Hey, is your name abc.txt, right? So you will kind of, okay, grab an image of a hard disk and put it here and treat it as a temporary storage. Okay, so let's say I take up the file size. Okay, file size is important. Why the file size is important? At least you can tell me whether I have how much data I can read, right? Let's say the file size is 1 byte, then you can only read 1 byte, or 0 byte, then you cannot read anything. At least you will pull all kinds of things, put it here in the kernel. We call it file attributes. And other kind of attributes is something that you never thought of. It needs to be handled inside the kernel, which is okay. Yeah, I know iPhone. Okay. So runtime attributes. So runtime attributes is something that you have it while the file is open. When the file is closed, it's gone. So what are they? I give you 2 examples. One example is the opening mode. Okay? I don't know whether you try it or not. I open a file, okay, as a read-only mode. How to open it as a read-only mode? F open, right? And then what? Double pro out, read-only mode. Did you try calling F printf? Okay, how many of you still know what's F printf? What's F printf? F printf. No one knows.
Print the file.
Yeah, print the file, right? So did you try open read-only mode, but call fprintf? Do you know what will happen? You never try, huh? No problem. I try. Okay. No matter if it's Linux, Mac, Windows, they all behave the same. So I choose my Mac machines to do the demonstration. Okay, so I just go to a temp directory. I will use Pickle because it's colorful. Oh, maybe I choose another guy. Sublime. Test.c. Okay. So make it bigger so that you can see it. Alright. So we will open a file as read only. Let's say I open a file. The file name is called test.c. No problem because this is my program code file. Okay. Test.c. Make sure you open it as a read only or I will destroy the source code. Then as a good habit here, close it. Okay.
return 0. Now what will happen if I do this? F, and then I will say, haha, he, okay? Yeah, so many men here. Alright, what will happen?
Guess. Do you think that there will be compilation error, first of all? Compilation error. If no, then will there be any execution error, like segmentation fault, runtime error? Segmentation fault or something.
Okay, let me first get ready. Terminal. Alright, so I'll compile that. Test.c.
Who think that I will get compilation error? No one, huh? No problem. Okay. When I run it, how many of you will think that there will be segmentation fault or any kind of runtime error? Okay, so at least you are very puzzling. Okay, you are very confirmed that there is a runtime error. So how about others? Hard disk corrupt, explosion, kernel just stop and you have to reboot.
Or you don't dare to try.
Nothing. So what happened to my source code? Okay, will my source code become
Yeah, that's why I choose he. Let's take a look. I will get test.c.
What is going on? It seems that it allows you to open a read-only, no problem, because we all tried before during the data structure course. We print data to the file, but there's nothing happen.
Now, maybe I show you something more. Show you something more is we can edit it here. How about I put a P error here to show the system error. Okay, this is a string that I call haha. Okay, yeah, no problem. Whatever things you want to add there will be print. Okay, now let me do a demonstration. If there is no problem, okay, so this fopen can open something successfully, then compile it, run it, will give undefined error 0. 0 means no error. Okay, now how about I do this? Now, as if I'm monitoring what happened after I call fprintf. Is there any error left in the system after I call fprintf? Compile and run. There's an error. Actually, there's an error. Bad file descriptor. Okay? So what is the meaning of bad file descriptor? It seems to be very hard to understand. Okay? That's very simple. First of all, you call fopen. Fopen associated with a file descriptor. That file descriptor is actually associated with this bunch of things. Okay? Including the runtime attributes, runtime and fixed attributes that dig from the hard disk. Yeah, really dig it up. Dig from the hard disk, which is runtime. So when you try to access it through a particular call, let's say fprintf, it will take a look at the runtime. The runtime attribute means that the thing that only created when you open it. Then what will happen? What will happen is it validates your runtime attributes, which is the opening mode because you want to write. Okay? So if this is very hidden, right? When you run it, it seems to be perfectly normal, but actually there is a bug. Now, what happens if I add a plus here? Huh? Do you know what is
R plus? What is R plus? You can open it, but at the same time you can modify it.
It's R plus. Okay. I remember in Windows it's RB plus, something like that. Okay. Run. This time haha say nothing. And what happened to my file? Castet.c. And here it's also will change. become Deutsch. Okay? Yeah, so this show you something, it really can modify that, and it's because from the kernel point of view, okay, from the kernel point of view, it's a group of items that when you try to call system call, you want to write something, you want to read something, it will look up this opening mode to see whether the opening mode allows you to do it. Okay? You can try the same thing. The same thing is you open it with a double quote W. Okay, so what is the opening mode of W? Write only. You try whether you can call fscanf. You cannot. Yeah, write only is really write only. You cannot write and then read it. But you can keep on writing, or you go back to the head of file and then write again. Yeah, that's okay. But when you go back to the file and start to read it, it will forbid you to do it. It's also because of this runtime attribute checking. And one more is about what I just said. What is the meaning of going back to the start of the file? Actually, there is a number, okay, the offset from the head of your file to the point that you were executing. Let's say you bring something to the file, then there is a, some people call it file pointer. I don't like that idea. I usually call it file offset because it's really not for just a number. File offset, or a proper name is called file seek, to what bytes you were at. Okay, so that seek is also hidden in this runtime attributes. If you want to know, okay, so there is a bunch of call. If you're using a fopen, this guy, ftell, yeah, to tell you what is your current location of your file. Let's say you have open a 1 GB file you are reading, okay, but you lost track where a particular byte I read, or where is it, you don't know. You can call ftell, then you will know which byte from the head of the file until you are pointing to there. It's called fseek family, or I just call it file seek. The fseek allows you to change that pointer. ftell allows you to read the position of pointer, so and so forth. Okay, some people call it pointer. Okay, right. So the system call itself is called lseek. The system call is very hard to call. I recommend you to use back the normal guy stuff. Okay, the library call fseek as well as ftell. Now, what is the next part? The next part is I will introduce one more guy to this big family. So what is that guy? That guy is a naughty guy, but wow, we will dig up everything. Step one, let's say I want to read something. Okay, I want to read something now after I open. And you have to read. You have to check whether there are available data. So this step is very important. You will check the file attributes for the file size and check what is your current position that you are pointing at the file. If you already go to the end, so you don't have anything to read. If you are not reached the end, then you will start reading something. And now I introduce you the kernel buffer, or kernel buffer cache, or kernel cache. There's many names there, okay, but we all refer to a buffer, a memory, or some temporary storage inside the kernel. So what is this buffer? It's a memory, not a disk, okay? There is a memory inside the kernel for each buffer, each file, and when you read something from the hard disk, it will temporarily keep it here, okay? Temporarily keep it here, and return the data to your client, your user, your program, okay? Now, why we have this kernel buffer cache? Of course, it's for performance. Usually, let's say you read something, and later on you want to read it again. So you won't go to the hard disk to dig it back. You will usually go to the kernel buffer cache to read it again. Let me show you some real data. So that real data is not included in this course, but in my Dropbox. Okay. So my Dropbox is about the elite class of last semester. where is the notes? Okay. Okay, in last semester we talked about some advanced feature in the file system. Okay. Oh, here. Okay, here is the statistic about showing the power of the kernel buffer cache. So what is this line is doing? Time is the measure for how long you execute something. You already know it, right? Now, what is this grep? Okay, grep, CUHK, Linux, blah, blah, blah. This command is to, we actually download a kernel source code, several thousands of files, okay? And keep in a directory called Linux, blah, 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 some versions, okay? So you imagine that there's a huge tree of files, more than 10,000 of files there. We look into every file using this command to look up a string called CUHK. We want to take a look at the kernel, whether there is a string called CUHK, and we really found something. Okay, some IE department guys have contributed code to the kernel, so we find CUHK. But this is not the thing that I want to showcase. I want to showcase is after running this entire command, you will see the real time that we need. Now you understand what is real time, what is system time, what is user time after assignment 1. You will see the real time is more than 2 minutes. Okay? And the user time, what is user time? Yeah, you dig up the file content, at least you need some code to understand, hey, whether there's a CUHK string inside there, right? So you will spend approximately 1 minute to look up everything that you read from a file, from the hard disk. And 1 second is from the system time. Now, after I finish this command, I do this command again. Now, magic happens. The total time that needed is reduced from close to 3 minutes to less than 1 minute. Yeah, so this is real capture, okay? I use a mechanical hard disk to demonstrate it. Okay, SSD is too fast, okay? You cannot see any difference. I use SSD. So here means you really go down into the hard disk to really dig something. So there are IO waits. You call a system call, you have to wait. You call another system call, you have to wait. Now here, why the time is greatly reduced? Because every time you call system call, the read system call, the previously called read system call data is already inside this kernel cache. So that is inside the memory, already inside the memory. Although the tree of data is huge, they are all kept here. And that's why you take a look at the results. The results is extremely fast, really close to these two numbers add together. Yeah, because they are purely memory lookup. Purely memory lookup. Okay? So of course I use a machine using mechanical hard disk, and this machine has 16 gigabyte of RAM, okay? So that I can cache everything. Alright. So this is what we call the kernel buffer cache and why we have it. Okay, why we have this kernel buffer cache. Now this is the read side only. How about the write side? When you write data, will this kernel buffer cache really useful? Yes. When it writes, what will happen? When you write something to a file, so you will go through the kernel, data is just shipped inside the kernel cache. Because when you want to write something, the kernel silently read it out to see what are the changes, okay? Then it will reflect the change only in the kernel cache. After update the kernel cache now becomes file content, and update the file attributes, because maybe your change is to grow the file, okay? And also change the file pointer, well, I don't call it file pointer, file offset, okay, that you were editing. Now, after this field change, the write system call return. Okay? Now, when you look at this diagram, actually the hard disk, can you find any arrows pointing to this guy? No. No arrows pointing to this guy. So what is the point? The point is we want to speed up write. As if this device is a floppy, I forgot to bring the floppy. Don't worry. How many of you don't know what is floppy? Okay. A few weeks ago, I dig picked this up from my office. Okay. So let's take a look at photos. Yeah, no, not this, not this. Photos. Yeah, don't care about those stocks. Albums. Hey, what are the mobile uploads? Or just timeline photo? Where are timeline photos? Here. Okay. Here. Yeah. I don't know why I can still find this in my office. Huh? And do you know what is this? This is a floppy case. When during my time, I buy floppy, I buy 10, and it is being hosted in this case. Okay, very beautiful case. 10 floppy put in here. Now I only have one left. Okay, I doubt whether it is still workable. Okay. Yeah. Do you want to play it next time? I ask you to ask someone to stand here to play for 1 hour. Okay. Really interesting thing to play it. Now, let's imagine that this is the floppy. I don't know whether you try using floppy. I tell you, floppy is an extremely slow device. Really slow device. When you write something, it will. I don't know whether YouTube can find the sound. Okay, you may Google floppy reading writing sound. Okay, it will okay, and writing 1.44 megabyte only take 1 minute. Okay, 1.445 1 minute. Okay, now let's imagine that if the kernel don't care about your floppy or your hard disk, even SSD, then you will have a very great experience. Is when you write something to the floppy, 1 second, and say that change done. You write something to the network, 1 second, change is done. And actually here, it don't care whether it is a network file system, it is a floppy disk, SSD, mechanical hard disk, because no change. The change only happened here. I don't know whether you experience it or not. Okay, usually you will experience it when you make the change in network file system. You want to copy something to the network file system. Sometimes it's very fast. Sometimes it's very slow. It's not depends on the file size. It's just like a random number. Okay, that's why I always say Windows sucks. To copy something, sometimes very fast. Okay, sometimes very slow. Okay, now it's because it's by the time that this buffer is full. What will happen? If it's full, you have to do something. What is that? You have to flush the data, we call it dirty data, flush the dirty data back to here. Sometimes it depends on the size of this buffer. This buffer is also depends on the system memory. If you have more system memory, this kernel buffer cache is bigger. If you have fewer memory, like 1 gigabyte of RAM, like your iPhone, okay, then will be smaller cache. And where can you find the cache? You can take a look at the reports that generated by top. Maybe I use Linux. Okay, wait for a moment. Okay. Yeah, very fast. It's just we spawn it from the snapshot. Okay, top. Too big. Let me make it smaller. Too big. Okay. Good. So here. Okay. Why this guy don't go away? Okay, I know I'm connected. Hey, go away. Okay, good. So this line is describing the memory status, and this is how many things is inside your kernel cache. Okay, and this number is varying. It depends on how frequently you access this. If you frequently access different type of files, this will be more. If you just boot up the machines, you can try. You can reboot your machine. Okay, yeah. If you just reboot the machines, the cache item will be relatively small. Okay, because you just start your system. Okay. Or by the way, don't start Chrome. Okay? Chrome is a memory sucking monster. Okay, it sucks a lot of our memory here. Don't start Chrome. Okay, so this is the cache. And now let me ask you these questions. My question is, now think, do you or should you remove a USB drive without clicking eject? Now this becomes a sensible question, huh? Let me ask you this question. It's based on your experience. How many of you have experienced this? When you click on the eject button, usually we will say bubble, yeah, save to eject. That save to eject bubble don't show up. There is some delay. Sometimes it's a 1 minute delay, sometimes it's 30-second delay. How many people have experienced that delay? You guys don't use USB. Okay, you guys just do your mind. Oh, Friday, okay. Yeah, if you use USB, you will experience this. What is that time? Do you know what is that time? You want to eject, and the kernels know that there are data still in the kernel cache marked as dirty data. Time to flush to this, but not waiting for that so-called time to time. It's immediate. Okay. Now, please flush, and remove the device. This is the time. Okay. That's why before I start this part, I asked you one question. How many of you have tried remove the USB drive and you find some data lost in the USB? Is it possible? It's possible because the data is not completely written to the USB, it's still in the cache, and you pull it out. Then your file is in a semi-written, semi-correlated, or in a corrupt state. I don't know. Actually, I don't know. I consider it as a semi-written state. Okay, half of it is correct, half of it is wrong. Okay, so which is possible. Okay, now question number 2. Then think about it. Why Windows or even Mac, Linux have shutdown sequence, but not just directly pull the power plug and shut down the machine? Now, same reason. This is the naughty guy, kernel buffer cache. Because the operating system actually opening many files. You don't know how many files it is opening, but eventually it's associated with process. So whenever you close a process, terminate a process, it will automatically tell the kernel that, hey, I opened the 10 files. Please help me to flush all the dirty data if it exists. Flush to the hard disk, flush to the maybe a network drive, USB drive. Please do so. Okay? So that's why there is a shutdown sequence, okay, to allow you to flush everything back to the hard disk, or something more. Let's say your system have a database. Now the data flushing is not flush to the hard disk. It's not that easy. It's flush to the database, flush to the network. Okay. So this is the reason, and this is all because of this kernel buffer cache. Now you should ask the question: hey, how about Arduino? Yeah. How many of you have played Arduino? Yeah. Some IE course already give you Arduino, right? And Arduino can read FAT32 file system, can read SD card. Now you should ask yourself, hey, is it safe? Is it safe to pull the power plug if I allow my Arduino module to read an SD card? Don't worry. Yeah. If for Arduino, they have their own ways to guarantee it. Now we should change the question is, hey, how about Linux? Can I safely mount something so that I see the system call finish? It is not finished there, but finish in the hard disk side. There are ways. There are ways. Okay. I said Linux, huh? Let's go to Linux. Okay. So there is a system call mount. Okay, and also a commands called mount. Okay. So what is mount? Mount will show the file system that currently used by your Linux. Let's take a look at what are the things that are being used. Let me show you something that you know. Here, the first line. DVSDA1. My SATA hard disk partition number 1. So this SDA, A means first hard disk, 1 means first partition, on the root file system, on the root. So this is the root data and it's now with a bunch of options here. Okay, so what is this option? It's about how the kernels react to this hard disk. And one of the options is called direct, not directory. Direct, I want direct. No, direct. Hey, come on, so many directs. Okay, I use another keyword, sing, S-Y-N-C. Sing. Come on, show me here. Take a look at this sentence. Start from here. OIO, that means input-output system call, to the file system should be done synchronously. So what is the meaning? In case of media with limited number of write cycle, I don't care. Write cycles, just like SSD. Do you know SSD have write cycle limit? Okay, good. Okay, so this is the normal class. Okay, last semester I asked CS class. Okay, they have 200 something people. Usually 100 people comes, and I asked the same question. Hey, do you know that SSD has a wearing problem or write limit problem? No one knows. They just buy SSD, okay? And SSD problem, go away. Yeah, they don't know about this. Okay, actually there's a write cycle limit on SSD. Yeah, so don't put your important data on SSD. At least you think that you want an SSD to keep it. Just try to search for 1 year, approximately 1 year. So move to another SSD. Okay. So this is the synchronous option, and you see the read only option, read write options. Okay. So there is just a very normal, very common options that you will find in mount commands. So when you mount a USB, you can choose the option sync. Then it will automatically flush everything. And tell you the truth, I remember that Windows, starting Vista, they actually silently mount every USB drive, at least USB, okay? USB drive, thumb drive, using the same options silently. Yeah, you can compare. Let's say you plug in the Linux, your USB drive plug in Linux. Write very fast. You remove it, plug in Windows, very slow. Why is that? Because it's automatically turned on the same in Windows. But in Linux, it's optional. Some distributions say yes, we have to protect our user because our user are very stupid. Yeah. So they have to protect us from stupidity. Remove it accidentally. Okay. So any question about the kernel buffer cache? Any questions? Or you still have some mystery from your life before this class, okay? Before this class, you encounter so many problems, you don't understand what it says, okay? Yeah, I'm here to tell you why. Any problem? Any strange things like you plug in I don't know what kind of thing, but suddenly it's drop something, okay? Maybe I can guess the reason. Usually my guessing is quite accurate. All right, so this is about a class discussion as well. Okay, I already discussed the problem with you. I will improve the reading performance. Yes, we know how it increases writing performance is, of course, you write to the RAM, not in the device, and silently write it back to the hard disk without your awareness. Okay, so we go to the last thing before we go to the file system layout. The last thing is, what is a directory? We all know what is a file. File is easy to understand. It contains data. I have an MP3. It contains MP3 data. It is a PDF. It contains PDF data. Oh, by the way, did I tell you what is magic number? No, I never tell you what is magic number. Okay. So, in your life experience using Windows, how Windows distinguish one file type, let's say DOCX, how it distinguish DOCX from JPG? I already say it out, right? It's distinguish of DOCX from JPG using extension. Linux, Mac,
don't do this. Okay, Linux and Mac don't care about extensions. Okay, what they are doing
is about file content. I don't know. How many of you already know about this magic number? No one knows. Good. Okay, so this test.c here. I save it. Now it should be empty files. Okay, 0 bytes. And there is a command in Linux, in Mac. They all use this command to understand what is the file type. It's called file. Empty. Okay. So I remember in the lab in a Linux workshop we play around this. Okay. Now I try to add a GIF what? 89A. Yeah, something like that. Okay. I write down GIF 89A as plain text. Save it in the test.c file.
Then it becomes a GIF.
I remember the PDF is something like this. Percent PDF minus 1.3, something like that. Okay. Yeah.
What do you want? What else do you want? Yeah, this is also a thing that is not related to file system design. File type itself is determined by its content. Okay? So the file content, you may ask, hey, how come a Windows double-click something is open something correctly, is okay, is obey the extension. Okay, you can try. You create a JPG, rename a JPG in the DLCX, then you should reboot your computer. This guy smiles, so he tried. He tried before. Do you know what I'm talking about? You have a JPG, a.jpg, rename it as final exam solution.docx. What will happen? Double click it. Then at least the word will crash. If you are out of luck, your computer crash. Okay? It's because it follows the extension. It's so stupid. Okay? It's actually following the content of the file. Huh? The content of the file says what this guy is. But of course, as a geeky guy like me, I know how to pretend to be particular file type. We call it a magic number. Okay, this is a magic number, a string to represent the file type. Like JPEG is not easy to type out because it's used a hexadecimal value that is greater than 128. I cannot type through my keyboard. I have to use a program to generate it. Okay, but every file has its own type by its content. It's designed by its content, not by attributes, not by directory, not by file name. Okay, now we go on to talk about what is a directory. Okay, so I don't know whether how many of you have tried by yourself to open a directory using VIM? Yeah, so yeah, what is the output? All the things, yeah, all the things in there. Okay, so actually what VIM is doing, VIM is actually executing my program. Okay, there is a set of library calls for you to open up a directory and read the content. Okay, this may be useful like you write PHP program. Your PHP program want to dig out your web folder, what are in there. They actually do the same thing. Okay, there is a library call, just like file pointer. Now this is called dir pointer, not fopen, but open dir. Yeah, it's very hard to understand. And why is it not called dopen? Yeah, I love to call it dopen, but yeah, they are not called dopen or open dir. Okay, and very interesting. Directory has only one opening mode, read only. You cannot write to a directory. Now, let me ask you, what is the meaning of writing to a directory? Huh? Yeah, create files, right? Any more? Yeah, you already give a big hint. Yeah, create a file, then you update the directory, right? How about delete the file? Yeah, you also update the directory. Change some files names, then you will update the directory again. Okay? So, but when you want to look into it, this library only allows read only access. When you read it, then you will call this read out call, just like string token. String token, you keep on calling it, then you will suddenly find that, oh, it returned out. That means it reached the end of the token list. Now here is the same thing. You keep on calling read out, keep on calling, then until it reach null, then you cannot stop. You can read something. Now one day, there seems to be just an encrypted message here. Now don't worry, I will show you the look. The look of that structure, this structure is called directory entry, DIRENT. Directory entry contains at least two commonly used and useful data. First, we call it inode number. So what is inode number? Don't ask me why it's called inode, because it's not the type. Okay, the type is when we reach the file system structure. Then I will have a chance to tell you what is inode. This is an identifier number which is unique throughout the file system. Every file has a unique number. Okay, so actually you can use this number to identify, hey, is this file different from that file, or someone give me two file paths. It's actually, I want to check whether this two file path is actually using some shortcut to point to the same file. Yeah, we can compare the inode number to know what the content is and the name. Okay, so this name is a system dependent. So what is the meaning of system dependent? If FAT32, it has a certain limit. If it is NTFS, it is another limit, because different file system implements different length limit. Okay, so in Linux support too many file systems. I cannot name all the limits, but believe in him, this string will give you a null terminator, yeah, \0, and guarantee that it contains most of the data from its name. Okay, even though the name is a Chinese, Unicode, even Russian. Okay, yeah, it is all inside there. So when you see my program, you will understand. Hey, now what is the two outputs here? One is the unique ID, one is the file name. Now I will execute in front of you. Okay. So this is called a simple LS. Simple LS. So I have many control. Okay. So I will take the input, okay, as the name to open, and where is the input is from the first argument. Okay. So that means that I can input the directory that I want to open and use my program to print the contents out. And the content or the required stuff, okay, will be a while loop. After you call opendir, keep on spinning until you reach the end of the directory. Now let's try. Run the simple ls. Let's go to the root directory. How about that? So you will see a bunch of things. Let's say something that you may heard of. The device has a strange number like this. The home have a number like this. Maybe you're not interested in it. Maybe here, this directory. If you want to go to this directory, just type dot. Dot by itself means current directory. Okay. So you will see where is this program. This program is called simple ls.c. Okay. It has a unique identifier number here, and you can find this just really unique. Okay, so these are the thing. So you can also find the current directory and the parent directory. Right. So this is the reading directory routine. All right. So maybe we talk for one more slide and then we give you a break. So what is this slice? This slice is the source of all the evils. So what is this slice is about? This slice is about what happens if you want to modify the directory. Okay? So we basically have at least two important modifications. I don't care about the rename part. Okay? Rename part means that you change the struct dir entry inside there, the name part. Okay, just rename. Now, how about we create new files? Create new files, maybe you can think of this directory as an array of structures. is an array of structures, one by one, one by one, one by one. Okay, and you can use the read there out to give you the next entry. Now, if you want to insert a new file inside your directory, so it cannot say that, I want to sort it in a particular order. Okay, it's actually don't do this. Okay, it will go to the end of the directory and insert a new array element. Okay, and call this a new file. So you take a look at this output. Okay, I just follow the most simple looping style. I don't change anything. Is it sorted? No, it's not sorted. Not sorted. It's sorted in one order. It's not sorted in this order. It's not sorted in order. It's actually doing some really lousy way. You create a new file. So, okay, I put it in the end. Do you believe in it? Let's try. I create a new file. It will be in the end. Now I touch xxx.yyyy. Okay, unique file. Run it again. Oh yeah, no. So yeah, we're very close to the end. Maybe there's a slot there. There's a hole there, so it's occupied that hole. Oh, by the way, why there is a hole? Good demonstration. Yeah, why we have a hole? Usually a hole is generated by removing an existing file. Yeah, you remove an existing file. What is the meaning of deletion? Yeah, usually most of I never find a file system will remove file content. I never see any file system do this. You can trust me. I do file system research. Okay, I hack kernel, I modify kernel, I create new file system. No such file system will cleanly remove every content, but they will clean up one thing: directory. Just clean up directory entry so that you lost your unique identifier, you lost your name, so that you cannot find where the content should be dig up, because you lost your ID. Yeah, let's say you lost your ID card. Okay, I can say that you are not someone should stay in Hong Kong. Yeah, go away. Yeah, we can do this, but here we can do another way around. Maybe you scan the disk, scan the hard disk to find the hard disk. Hey, can I find some deleted file content based on what is left inside the hard disk? But this is another story. It's about assignment 2. Okay, but here you can find there's a hole being generated when you delete the file. And the previous demonstration is very nice. I create a new file. So happen that it find the holes occupy the old hole there, so that you don't need to expand this list again and again and again. Okay, so this is file deletion and file creation inside a directory. And what are the other information that is stored inside the directory entry? I just mentioned to you. Actually, they are all the directory attributes. Sorry, it's not directory attributes. File attributes, like your file size. The file size is here. Actually, the file size is here. Permission, ownership, they are all stored inside here. So that's why when you go to Windows, okay, I don't have a Windows here, but you can use your Windows. You right-click your File Explorer, just right-click that file. I think you can sense it. Let's say your file is a huge one, 2 TB. I don't know why you have 2 TB file. Okay, you right-click it. It gives you the information. Just use less than 1 second. It's don't need to go down to the 2 TB and this 2 TB is really 2 TB. Okay, yeah, it's not going to be like that. It's don't go down to the file to count, but go to the directory entry to dig up every attributes. Okay, so this is directory. Maybe I give you a break. We just have a few slides left, one or two. Then we will go to start the next part. It's about the design of directory. Yeah, it is fun. Yeah, understanding the design of directory is really fun. It's part 2. Okay, let's have a 5 minutes break. Right. So, what should you do? So you can take a look at my PowerPoint. There is an option called D. D means that I'm not interested in the directory content. I'm interested at the directory itself. So, what will be the results? The results will be D
Then you will see the user's information, the permission, who owns this, so and so forth. But instead of going inside there, okay, so usually I will use the D options. Now, why I have to tell you the D options? Because I want to demonstrate, I will demonstrate now, you believe in me, you can try by yourself using Linux, Unix, even Mac will be the same. You create the directory content that actually, what can you see? This is the directory content you just create an empty file, and this is the modification time of the current directory you are in. So let's compare this to this. Okay? Before you do any change, the modification time is some day, 2010/11/16 in the night. Then you create a so-called final.xls, then it will update the directory itself. Also remove it. Okay? So this is about changing the directory content. So basically we have these two control. Now we will go to the next part. What is the next part? Next part is interesting. Every